In the midst of the big show of the universe, we waver at the cusp of Earth, breaking exposures that responsibility to adjust our standpoint at the universe. The presence of the James Webb Space Telescope fosters the extent of our tremendous evaluation, assessing further into the favored bits of knowledge of fact than any time predicted. Leaving on this new pursuit through James's information, we offer a person's observe the uncommon early universe out on this manner, depict modern-day incalculable requirements as we revel into this illuminating vicinity. The mosaic of our appreciation spreads out, revealing unconventional plans and disguised intricacies. They oblige us as we plunge exceptional into how James Webb definitely perceived huge plans that ought to not exist. Could you ever imagine investigating a time machine, revealing memories from age to work out insistently? The James Webb Space Telescope has carried out essentially that. It is, for the maximum part, a large subject picture created from a mosaic of 690 man outlines. It depicts a repair of SK in area. The large scoops address commonly on multiple occasions extra noteworthy than its ancestor. It's like maintaining in a cosmic jigsaw puzzle wherein each piece is a particular universe from the early universe. These pictures present a complicated dance of systems, some of which existed essentially in sizable amount of essential time spans after the high-quality impact. Their sensitive shimmers are a quiet affirmation to their distance and age, revealed via the unequaled toddler responsiveness of the near-infrared digital camera. This observable and big bounce in bombastic evaluation yields top-notch reconsiderations into the universe's net testimonies. As much as now, maybe the exceptional divulgence earlier than 100 prolonged lengths of its far that are domestic to zero in on the universe changes. What's more, it makes with time, not certainly in minor unimportant ways like stars transferring about gasoline hazes, urgent and huge stars bombing hopelessly in tragic impacts. No, our whole universe has modified its fundamental appearance, at least extra than one instances within the remote past, genuinely changing its interior state at an ordinary inescapable scale. Take, for example, the reality that at one time in the overcast, iller past, there had been no stars. We recognize this vital fact in mild of the way that of the presence of the unfathomable microwave basis, a power of sensitive but innovative radiation that soaks the entire universe. Assuming that you enjoy an inconsistent photon, a smidgen of moderate, there may be an first-rate possibility it is from the vast microwave basis. That moderate takes up greater than 99.99% of all the radiation in the universe. It is a further from when the universe became only 27,000 years vintage and stepped forward from a hot, disturbing plasma right into a sincere soup, and not using a terrific or negative charge. Exchange conveyed white-hot price radiation that, all through the scope of 13.8 billion years, chilled and stretched out off into the microwaves, giving us the status quo slight that we are able to understand nowadays. On the season of the presence of the cosmic microwave foundation, the universe became spherical 1/1,000,000th its ongoing quantity and extensive number of stages. Reality being told, shaped, it was too basically uniform to bubble with density variations no more than one phase in 100,000. So not conclusively a country in which stars should joyfully exist. Inside the length following the transport of the cosmic microwave basis, delicately called WMX in vicinity technology circles, the universe changed into in an ordinary nation. There was a steady shower of white warm radiation, but that rotted part became suddenly cooling as the universe went on with its relentless improvement. There was faint predicted final results putting out, disdaining its personal commercial enterprise, and there was the at this factor unbiased gasoline, essentially hydrogen and helium, ultimately set free of its fights with radiation and loose to do what it satisfied. Luckily, it didn't want to fasten within the early universe. Little quantum dangers reached out to become handiest contrasts in thickness. And why that happened is a story for one more day. Those tiny thickness contrasts failed to impact the more significant cosmological benefit, but they impacted the presences of that truthfully minded hydrogen. Any repair that became to some diploma denser than everyday, even with the aid of an insignificant little piece, had to some diploma more grounded gravitational draw on friends, upgraded pull, requested more gasoline to join the party, which accelerated the gravitational power, which engaged considerably greater buddies, and so forth. Like excellent song at a close-by birthday party going, the same manner in alarm tune to help more rares, all through its massive, extensive style of years, the rich gas have been given more giant, and the mournful gas have been given less lucky via vital gravity. Little thickness contrasts created building the first big player of count number and tough out their environments. Somewhere some a part of real-minded hydrogen have been given fortunate, keeping layers, resulting in overwhelming layers on itself. The most profound center got here to a vital temperature and thickness, using tangled shape, carrying out nuclear fusion, and converting over the harsh substance into helium. That savage cycle to deliver a touch of energy and, in a burst, the chief big call become added into the sector. Seemingly starting from the hidden dozen minutes of the Amen blast, nuclear reactions came about in our universe, new wellsprings of light, dotting the universe, flooding the once void voids with radiation. Those new wellsprings of radiation re-energized the honest hydrogen that crammed the universe. In the course of the supposed epic of reionization, via gravity, more and more eccentric plans emerged, building a fantastic big weaving of universes. Inside the interim, the whole thing continued to fly remote. The stargazer Edwin Hubble taken care of out for the duration of the 1920s that the universe is broadening, and in the late 1990s, his namesake, the Hubble Area Telescope, tracked down affirmation that the augmentation is speeding up. Consider the universe as some a part of raisin bread. It starts as a mixture of bloom, water, yeast, and raisins. At the same time as you merge these decorations, the yeast begins breathing, and the detail starts off evolve to rise. The raisins inside, opportunity for structures broadening in addition, far away from one another. As the element fosters, the Hubble telescope noticed that the piece is growing of all time quicker. The raisins are flying isolated at a fee that goes in opposition to their gravitational hobby. This speed growth emits an impression of being pushed by way of the horrible strength of room itself, passenger faint power that's wooden in well-known through the Greek letter lambda. Plug values for lambda bloodless, weak count number, common rely, and radiation into the territories of Albert Einstein's in fashionable speculation of relativity, and you get a version of how the attention encourages this lambda cold we depend number. One system for attempting out this picture is through looking at in specific remote mammoth systems, dubious from thinking again to the primary now not many 100 million years after the awesome a case that started out at all of the universe modified into greater honest than its headway, more straightforward to research towards assumptions. Anyways, as examiners make use of James' Internet to dive into the underlying segments of the universe, they found something that shouldn't exist. These amazing exposures then at that point positioned the educational neighborhood and problem in that they have got to have a look at the very fundamentals of what they familiar cosmology explicitly almost following the NET telescope completely grew to emerge as on in July 2022. James Webb's amazing infrared mindfulness discovered out the prone glint of universes in fact from the protracted way off universe that had fashioned basically numerous a broad time frame after the good full large effect. Location specialists had expected such accomplishment outcomes to emerge a lot extra relaxed, in any case extra than speculated. There was an impact of information. The one's early results take place so swiftly, thinking about the manner that analysts applied a clever essential path to test excellent distances. Cosmologists, for the maximum factor, stuck down countless route via logical ly comparing crimson shift, a loosening up of a universe's mild toward the crimson end of the electromagnetic obtained because of the universe's improvement. But this requires the advent of social occasion and investigating, and countless structures come to a time-consuming and unpretentious technique referred to as spectroscopy. The James Webb Space Telescope's first hose of revelation became absolutely fueled via cruder quicker photometry-based totally strategies that basically utilize smooth combos in a system's brilliance to absolutely check their pink exchange. As such, while the photometric results came thick and fast, the preceding summertime, the spectroscopic results have commenced streaming, however, with the useful resource of an exceedingly restrained factor out as of now. At any price, with spectre generally L-based totally distances, close by from something like 12 candidate researchers are finding that most price determinations are matching the early photometric results. The most recent appropriated in Nature Astronomy certifies previous distance measures for more frameworks diagnosed by means of the Farad Big Extragalactic Outline, as shown via Emma Curtis P. of the College of Hure in Britain who drove the spectroscopic effects. We had been accepting that this could have the choice to do it within the crucial start quite a couple of months. This telescope became without a doubt superb fastic. Of the four, the most distant is united with the pretty stumbling call Gonzi. It has a pink shift absolutely really worth of 13.2, which approach we are seeing the form as it appeared handiest 320 million years someday later the large explosion. That excessive pink shift makes Jade Zero the most far off at this point appeared within the universe, a report that the James Webb Space Telescope seems set to interrupt all another time yet one inescapably that highlights area professionals, so the nuclear focuses collectively and inspired. We, at this factor, point no for unequivocal we strive a length of the universe no human has at any direct looked at Advan in the direction of its impressive, says Peter Van Destruction of Yale School. This cosmic form, he interestingly notes, I simply slightly greater settled from our factor of view than the trendy time sharks have existed on the global about 300 million years. As such, you circulate from nothing to those unquestionable universes inside the glint of an eye fixed. However, not all excessive pink shift competitors in admirable systems were so fortunate, which highlights cosmologists' early attention. In July, another blueprint called the Endless Movement Early Delivery Generation, evaluated through Felstein, highlighted a viable universe at a crimson shift of 16.4, most effective 240 million years after the giant blast. Coming to fruition, spectroscopy has shown that settlement become as stray as revealed in overdue march in studies led by means of Pablo Arabel and cosmologist at the National Science Technology Founded or No Lab. The arena is the whole lot to notion of a dirt surprise and waves that to date this universe is taken into consideration a dusty funny story, operating at a pink shift of 4.9, nonetheless vivid, however not record-breaking. 1.2 billion years after the giant effect, raised stages of star development are made of the early universe. In each of those universes, the group tracked the formation of billions of solar masses, which were believed to have an estimated 75 million years after the giant blast and universe end by looking. Researchers concluded, I express regret for the confusion earlier. It appears there's some trouble with the text you have provided, making it difficult to interpret as it should be, but I will try and continue from wherein we left off. Made of the early universe. In each of these universes the group tracked the formation of billions of solar loads which were believed to have an estimated 75 million years after the giant blast and universe visible by looking at researcher concluded that these early universes are minimum of times of the same old universe. Explaining that these early universes have provided challenges and studied that as a few he and which have hopped the discussion appears to cognizance on observations made viable by way of the James Webb Space Telescope JWST and its effect on our know-how of the early universe. Here's a dependent continuation. The James Net Area Telescope launched in 2022 has significantly superior our ability to study remote galaxies and the early universe. It uses infrared generation to look deep into space, allowing astronomers to detect faint indicators from galaxies that shaped billions of years in the past. This capability has led to groundbreaking discoveries consisting of figuring out galaxies at record-breaking distances with purple shifts as excessive as 13.2. These observations challenge preceding assumptions about the timeline of cosmic evolution. For example, galaxies determined at such excessive red shifts, fashioned only a few 100 million years after the Big Bang, pushing our know-how of while and how galaxies first emerged in the universe. Moreover, spectroscopic information from JWST have showed these remote galaxies' distances and traits, validating earlier photometric measurements. This affirmation is essential for refining cosmological fashions and expertise, the procedures that drove early galaxy formation and evolution. The telescope's potential to behavior rapid photometric surveys has supplied a wealth of facts, speedy enhancing our information of the early universe's dynamics and structure. This includes insights into the epoch of reionization, when the universe transitioned from a neutral kingdom to one dominated by means of ionized hydrogen. In Précis, the James Net Area Telescope represents a substantial bounce forward in observational astronomy, permitting scientists to discover cosmic epochs previously inaccessible. Its findings maintain to reshape our know-how of the universe's origins and evolution, providing new perspectives on essential questions in cosmology. Early universe observations. Formation of early galaxies. The JWST has determined galaxies at crimson shifts more than 10, which means we see these galaxies as they were only some 100 million years after the Big Bang. These early galaxies seem to have shaped stars at a far quicker charge than previously expected, suggesting that superstar formation in the early universe became more green or took place below exceptional situations than in later epochs. Excessive crimson shift galaxies. The invention of galaxies with purple shifts as high as 13.2 indicates that those galaxies existed handiest about 312 million years after the Large Bang. This challenges the knowledge of galaxy formation timelines and shows that the first galaxies formed in no time after the universe's initial enlargement. Technological improvements. Infrared observations. The JWS near-infrared digital camera and cam and mid-infrared tool MIRI allow it to hit upon faint and distant items by shooting light in the Infrared spectrum, which is vital for gazing excessive crimson shift galaxies whose light has been stretched into the infrared by way of the universe's growth. Spectroscopic affirmation. The telescope's spectroscopic abilities, such as the close-to-infrared spectrograph NIR-SPEAK, provide unique measurements of the purple shifts of distant galaxies. This allows astronomers to confirm the distances and homes of these galaxies. With unparalleled accuracy, cosmic reionization, epoch of reionization. Observations from the JWST offer precious information, approximately the epoch of reionization, a period that commenced about 400 million years after the huge bang and lasted until about 1 billion years after the large bang. In the course of this time, the primary stars and galaxies fashioned and ionized the encompassing hydrogen fuel, making the universe obvious to ultraviolet light. Cosmological implications. Dark matter and darkish power. The findings from JWST have implications for our understanding of darkish be counted and dark electric energy, the formation and distribution of early galaxies provide clues about the nature and behavior of dark count number, at the same time as observations of the universe's growth make contributions to our information of dark energy. Cosmological models. The surprising rapid formation of galaxies and their large loads suggest revisions to current cosmological models. Those fashions ought to account for the green and early star formation and the assembly of massive galaxies within the universe's infancy.